Okay guys, today we're going to be doing 3.2, a definition of a derivative, or you could also call this the slope of a tangent line. Remember, secant line is the average rate of change, tangent line is the instantaneous rate of change. Okay, first thing, we're going to do a little warm-up. Get this set up here. Okay, we're going to do a little warm-up. Okay, sorry about that line, just ignore it. Estimate the slope of the tangent line at 2 using the slope of a secant line of the function. Okay, it says estimate, remember the key words, estimate the slope of the tangent line. I said instantaneous rate of change before, estimate the slope. Okay, that's going to be f of, remember you pick values close to 2. So this is your a value, your b value is going to be something close to it. I can use 2.1. So f of 2.1 minus f of 2 all over 2.1 minus 2. And you would just plug in 2.1 into this function, figure out what this is, plug in 2 into this function, figure out what that is, divide it by 0.1, and you got yourself an answer for the estimation of a tangent line. Or remember, tangent line means instantaneous rate of change, an estimation for the instantaneous rate of change. Okay, let's go forward. Okay, first thing is, I'm going to tell you what a derivative is. It's the slope of a tangent line, or instantaneous velocity, which you can also think of velocity as being rate of change at any point. Okay, so it's going to tell us the slope. So derivative is slope. Slope. Okay, that's just an easy way to remember. A one-word definition for derivative is slope. Okay. So let's see what we got here. You're going to write this down, okay? This is important. This is the definition. Now let me explain that definition real quick so you aren't confused at where it's coming from. On the last slide, I told you to find the estimation for the instantaneous rate of change. We did f of, sorry, I didn't use x, f of 2.1 minus f of 2 all over 2.1 minus 2. Now, this function is for average rate of change. Well, Isaac Newton was saying, I don't want an average rate of change. I want to find the velocity right at 2. So he looked at this function, he realized, well, let's see what it is I'm doing. I'm doing some function. I'm taking my x value. I'm adding some small amount to it, which was 0.1 in this case, subtracting it from my function at 2, all divided by, if you see 2.1 divided by 2, that's dividing by that small fraction I had added to the value. Well, if we don't think of it at 2 and we just think of it at any point, we can say this is f of x plus h minus f of x all over that little change right there. Now notice that's the same thing in the middle here. What we want that little change to be is, remember, we want this little amount to be as small as we possibly can. Remember in the last PowerPoint, for one of the values I even chose 0.001. I was getting as small as I could. Well, we had learned in the last chapter that a limit, we can talk about where it's approaching. So let's just, instead of picking a value that's really close to 0, why don't we do a limit as h approaches 0? And then that's where this is going to be. It's going to be as close to 0, so as close to 2 as it possibly can be. So that's where this definition is coming from. And that's an important definition that we'll be using today and the rest of the semester, actually. Okay, now here are a bunch of different ways to say derivative, okay? You can write it out as f prime of x, dy over dx, y prime, or instantaneous rate of change, or you could also say tangent line. I told you guys that's what we're doing. Slope of a tangent line. Okay, that's another way of saying it. So we got a bunch of different ways we can say derivative. Okay? Okay, first one, it says find the derivative of this. Okay, well, we're going to use that derivative function we were just talking about, the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, well, we are going to be using the function for f. Okay, now for this first part here, we're plugging in x plus h. So we're going to have the limit as h approaches 0 of 3. Now wherever there's an x, we're putting x plus h. That's what this means. X plus h plus 2. Okay, now look, I'm going to put that in parentheses because that is this whole first portion right here. Okay? That's that. I plugged in x plus h wherever there was an x. Okay? Sorry, my battery's dying over here. Okay. Now I'm going to subtract f of x. Well, this is f of x. So let's put brackets for that one too. 3x plus 2. Okay, that's the brackets for this guy right here. All divided by h. Okay, now remember, limits. First thing we're going to do, we're going to try to plug it in and see if we get an answer. Now if you notice, if you plug it in, you are dividing by 0. And we can't have that. So we need to go to the next step, which is trying to cancel stuff out. Yeah? So let's try to cancel stuff out. If you do this right, a lot of things will cancel out. The limit as h approaches 0. Okay, inside of that first parenthesis, I'm 3x plus 3h plus 2, because I distributed that 3 into both of these, yeah? And then minus, I'm going to distribute this negative into both of these, minus 3x minus 2 all over h. Well, if you notice, I still can't plug in 0, because it's still going to give me a 0 on bottom. So let's see if anything cancels out here. I got 3x minus 3x. Those cancel each other out. I got plus 2 minus 2. Those cancel each other out. I'm just left with the limit as h approaches 0 of 3h over h. Well, h is canceled, leaving me with the limit as h approaches 0 of 3. And there's nowhere to plug in 0, so that's our answer. Our answer is 3. Okay, so the derivative of this thing is just 3. So that means the slope of this everywhere is 3. And that's easy. That makes sense because we know what 3x plus 2 looks like. It crosses through the y-axis like that. It has a slope of 3, right? Everywhere it has a slope of 3. And we just figure that out. It has a slope of 3 everywhere. Now some things that they'll sometimes ask is find the derivative at a point. So what is the slope at 2? Well, we know the slope everywhere is 3. That's what we just figured out. So the slope at 2 is also 3. Okay, let's go on to a more difficult one. Okay, so we're going to do the same thing. The limit as h approaches 0 of f of x plus h, and I'll put all this in brackets so you can denote what I'm doing here, minus f of x all over h. Okay, so we're going to have the limit as h approaches 0. Okay, I'm going to plug in the first one. I'm going to plug in x plus h wherever there's an x. So 3 over x plus h minus 3 over x. Right? I plugged in x plus h for this one. So this is the first part of that whole thing, and this is the second part. So the first part, the second part, all divided by h. Okay, now we can't plug in yet because that would leave a 0 on bottom. So we have to figure stuff out. We need to combine this out. So a common denominator is how we're going to do that. So we're going to have 3x plus h. We're going to have to multiply this by x over x. Multiply by the other one's denominator. Minus, 3 over x. We're going to multiply this one by x plus h over x plus h. All divided by h. Okay. Now let's just multiply the top in. So we're going to have on the top 3x over x plus h. Notice I didn't distribute the x on bottom. You'll see why in a bit. And I just multiplied across there. Minus, I'm going to distribute this here. So 3x plus 3h all over x plus h, all divided by h. Okay, we just got a couple more steps here. Now, this negative can be distributed into both of these. Okay, so we're gonna put our fraction together. We'll have on the top 3x minus 3h all over x over x plus h, all divided by h. Yeah, and we're still doing the limit as h approaches 0 of that. Okay, well, I want to put it as a full one fraction, so I'm going to put h over 1, and I can do that sandwich method. So what we'll have, and first, before that, notice that things can cancel out. 3x minus 3x leaves us with just negative 3h. So negative 3h times 1 is negative 3h over x times x plus h, all times h. And we do the limit as h approaches 0. Okay, notice if I plug in 0 now, it still leaves me with a 0 on the bottom. But I can cancel h's now, leaving me with negative 3 over x plus h. Now, I'm still doing the limit as h approaches 0. I can plug in 0. If I do that, that leaves me with negative 3 over x times x plus 0, which is the same as negative 3 over x squared. So now I have an equation to find the slope of a tangent line. So an equation for the slope of a tangent line, or the instantaneous rate of change. Okay? So they might ask something like, find f prime of 3. So in order to do that, you just plug in 3. Negative 3 over 3 squared. That's going to give us negative 3 over 9, which is negative 1/3. That's the slope at t equals 3. Okay? Remember, the slope on this graph is going to be different everywhere, but at 3 it's negative 1/3.